All right, welcome again. This time around, we'll be looking at the converse theorem, of the first theorem that we did in the previous video in lesson 2. So for now, we'll just call it theorem 1b. All right. So now we have the new statement here that we are bringing to you, which is converse. So what is a converse? Converse would refer to the opposite of what is written here. Or we could look at the previous statement, the theorem, which said the line drawn from the center perpendicular to the chord bisect the chord. Then this one says now the line that is drawn from the center that bisects the chord is perpendicular. You get the point? So converse would refer to opposite. So suppose the theorem says if A, then B, then the converse, which is the opposite of that, will then be if B, then A. So that is a converse theorem, simply the opposite of what has been stated. So if this is our theorem, then the converse theorem would be the opposite of that. So the conclusion and the hypothesis are switched around. All right. Okay, right. So the theorem that we are looking at today is the line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. So midpoint, we can just use as another word, which is to bisect. So the line drawn from the center of the circle that bisects the chord is perpendicular to the chord. So you can see the differences between the first theorem and its converse. It's just the switching position of perpendicular and bisects. So yes, so the line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. And the reason that we use whenever we are applying the theorem would be line from center to midpoint of chord. So every time you write that statement, we would know what it means, So a line that goes straight from the midpoint of the chord but drawn from the center of the circle is perpendicular to AB. So there's a formation of 90 degrees when the two lines are in contact. So that means OM will then be perpendicular to what? To AB at the point of contact. All right. So this, according to the theorem, it says if AM, it is given that AM is equals to MB, then OM will be perpendicular to what? To AB. If you still recall from the previous theorem, it was the line from center of the circle perpendicular to the chord bisect the chord. Then we said if OM is perpendicular to AB, then AM is equals to MB. That is according to the previous theorem. So now is the reverse, So the reverse, which is the opposite of what we've stated in the previous theorem. So now I want us to look at the proving of the theorem. So in proving the theorem, you'll be given certain information and you need to just complete it so that we can say we have proved the theorem. All right, so in the diagram, O is the center of the circle. OM bisects chord AB. That's what we are told. So let's use what we've been given. We are told that AM is equals to MB in this statement here. OM bisects chord AB. So if that is the case, okay, that's why we put those two lines there to indicate that AM is equals to MB. So they want us to prove the theorem that states that the line from center of a circle, or from the center of a circle, that bisects a chord is perpendicular to the chord. So they want us to prove that OM is perpendicular to AB because we are given that AM is equals to MB. Remember, OM goes straight to the midpoint of AB, and that line must be perpendicular to AB, 90-degree formation. So for us to ensure that OM is perpendicular to AB, that means we must then prove that M1 or M2 is 90-degree angle. One of the two. Just prove one. If one is 90-degree, then angles in a straight line will eventually be what? M2 will definitely be what? 90 degrees. All right. Now let's get to it. In geometry, most of the time when you do some proofs, especially the formal proofs, we need to have some construction done on the diagram. So this is our construction, just the same as the previous theorem. We did the same construction, constructing our radii. And we know that radii in a given circle are what? Radii in a given circle are equal in magnitude or size. Just say the length. Yes. All right. So with that, what did we do on our diagram? We drew a radii OA and OB. That's what we did. Then now, coming to the proof. So for us to prove, if we have to involve angles. So far we haven't learned much theorem, so we must rely on the previous knowledge that we have acquired in the past grade. So what we have learned is about parallel lines and congruence similarity. So in this case, we don't have parallel lines, so we need to deal with the congruency that may help us in terms of ensuring that the two triangles are the same. And if we do know that, then M1 will eventually be equals to M2. So in triangle AOM, so I'll just write them as they will be. So BOM. So this order would remain the same because already I know the order. So, but we'll still confirm it. So in these two triangles, we are given something. OM bisects AB. So that means AM is equals to MB. Let's start there. So AM is equals to what? MB. This is a given information. We are given that OM bisects chord AB. So, and again, in these two triangles, there is a common side. OM is a common side in both triangles. The common side. So, and we have the line that we just constructed there, which is OA. So OA is equals to OB. Why? Because it is radii, and radii in a given circle, we know that they are equal in length. So with that, we managed to identify three sides in both triangles to be equal, the corresponding sides. All right, then we can now say triangle AOM. And remember, with congruency, the order is very important, and with similarity as well. So, but as I said, that I already arranged those letters in a way that they're just in the order that we want. So let's just confirm, but we'll confirm with the side. Look, AM is equals to MB. So AM, so that means the first letter is A, the last letter is M. So in this case, the other triangle would be B, and M. If we look close to a diagram, M is it's a common point for the two triangles. So B will be the first letter here, and M being what? The last letter. Then again, we are told that OM is a common side. So OM is a common side. So that means in the middle here, we must have an O. And we can even confirm the OA and OB. So AO is the same as OA and BO. So you see that the order there is followed. Then if that is true, then we would say, okay, what did we identify? A side, another side, and another side. So that will be side, side, and side. So we proved the two triangles to be congruent using side, side, side. Okay, all sides or corresponding sides are equal. Okay, after this, now that we've proved that all sides are equal, that means the two triangles are congruent. So they're identical in sides and angles. So the order in which we have written our letters should be the same when we read the angles. So angle A is equals to angle B, angle O is equals to angle O, angle M is equals to angle M in these two triangles. All right. So in that case, we're looking at M1. That's where we are interested. We need to find out if there's a 90-degree angle formed there. So according to the congruency, it allows us to say angle M1 is equals to angle what? M2. So the two angles are equal because of the congruency that we just proved. So that will be triangle AOM is congruent to triangle BOM. Okay, now that we know that, they told us that AB is a chord, so it's a straight line. So we'd say M1, angle M1 plus angle M2. It must give us what? 180 degrees. Then we say these are sum of angles in a triangle. So at times we can say interior angles of a triangle. Okay, now that we have this, we would say, but M1 is equals to M2. So we can now replace angle M2 by M1 like this. So now we have angle M1 plus angle M1, which is then equals to 180 degrees. So angle M1 plus angle M2, that will give us 2 times angle M1, which is then equals to 180 degrees. So when you divide both sides by 2, then that is equals to 90 degrees. So you see now, angle M1, it is 90 degrees, but we also said angle M1 and M2 are equal. Therefore, M2 is also 90 degrees. So there is a formation of what? 90 degrees at the point of contact. That's what we just proved. So also M2 will be 90 degrees. Then we can conclude, therefore, OM is perpendicular to AB. Yes, so that is our conclusion. But if you just want to add, you just say since angle M1 is equals to angle M2, because both of them are now equals to what? 90 degrees. So when two lines come into contact and they form a 90-degree angle, we say those lines are perpendicular to each other. So that is the proof for the the converse theorem of the first theorem that we did in the previous video. All right, with that, I want us to look at an example that is applicable to this theorem, and let's see how that is answered then. All right, so now we have O is the center of the circle, B is the midpoint of KD. BL is 4 units and KD is 12 units. So let OB be equals to X. So one important, we are given a center. So when there's a center, we think of radii. Radii, if radii is there, then we are likely to have a type of a triangle that is an isosceles triangle. And back to our proof that we did, we are not limited to the proof that I provide or the procedures that I've provided. We can also prove using side angles side, because the two radii, they form a big isosceles triangle. So angle A and angle B are actually equal angles. Then we'll say angles opposite equal sides. But that's fine. Now let's come here. A says that express the radius of the circle in terms of x. Okay? Express the radius. The first thing we need to ask ourselves, what is a radius? So a radius is a line from the center to the circumference. The distance from the center to the circumference is our radius. And we need to know that all radii in a given circle, they are equal in length. So it's important that we understand the terminologies, yes, as we apply this. So radius is a line from center to the circumference. And if you look closely in our diagram, we have one line that runs from the center to the circumference, and that line is OL. So the line OL is our radius. It's made up of OB plus BL. So that will be OB plus BL. Do you see that? So this is our radius. So what is our OB? OB is given to be X. And what is BL? BL is 4 units. So this is our OL, which represents our radius. Then we can say the radius of the circle is X plus 4. So radius of the circle is X plus 4. B, it says that solve for x. So how do we solve for x? For us to solve for x, that means we need to have an equation. So you need to formulate an equation. And how do we then formulate that equation? Okay, so here we are given KD to be 12 units. Remember that? So, and we are told that in the same line KD, KB is equals to BD. So we need to know the value of BD at least. That will be half of that, 6 units. And that KB will also be 6. So they make up the 12. And another thing again that we need to know, any line drawn from the center of the circle to the circumference is called a radius. And all radii in a given circle are equal. So the value of OD should also be equals to x plus 4. So let's start there. OD is equals to OL. These two are equal. Okay, maybe let me not try that. Let's just say OL. This is because of radii. Radii in a given circle are equal. So therefore OD is also x plus 4. Okay, then we also said angle side BD is a half of KD. And this is what it is given to us. It is given that BD is equals to, what is that, KB. It is given to us. And we know that KD is 12 units. So that will be 1 over 2 multiplied by 12, which gives us 6 units. So now that we know the length of BD is 6 units. And okay, We know OB, we know OD, we know BD. It's a triangle, but now it is not established to be the type to be what type of triangle it is. So we need to sorry, we need to find out the type of triangle it is. So likely we need to find the right angle triangle. So for us to have a right angle triangle, we need to make sure that there's a 90-degree angle somewhere. But we just learned the theorem that says a line drawn from the center of the circle to the midpoint of the chord. They told us that B is the midpoint of KD. So that means it cuts the chord KD in half. So that point B is the midpoint. So that's why KB is equals to BD. And the theorem says that the line drawn from the center to the midpoint of chord is perpendicular to the chord. So if we do have a line from the center which goes to the midpoint of the chord, so therefore there must be a 90-degree that is formed at the point of contact according to the theorem. So that's why I'm adding the 90-degree there. So we'll then say, okay, angle OBD, the angle between O and D, it is equals to 90-degree angle. Why? According to the theorem we just learned and proved, it says line from center to midpoint, line from center to midpoint of chord. So that is the reason behind this. Okay, now that we know that there's a 90-degree angle, what type of a triangle is formed? It is a right-angled triangle. So if it is a right-angled triangle, then we can use the theorem of Pythagoras. You see. So with that, in triangle OBD, we can say that OD squared is equals to OB squared plus BD squared. This is because of the Pythagoras theorem. All right. So now what is OD? OD is in terms of x, remember? That is x plus 4. Then you square that. OB is x. Then you square that. So it is good practice whenever you make substitution, you put the values inside the brackets to avoid the issue of signs. Okay, so BD, we just proved it to be 6 units, or it is given to us. Then when we expand this, it will be x squared plus 8x plus 16. So that will be x squared plus 36. So 6 squared is 36. So with this being said, let us now take 16 over the equal sign to the right and x squared to the left hand side. And if that happens, would realize that x squared will subtract x squared, because if it crosses over, it will be x squared minus x squared. So that means on the left side we have 8x. Remember, I'm still going to take the 16 over. So if I take 16 over the equal sign, then it will be 36 minus 16. That will give us what? 20. So we have 8x is equals to 20. We then divide both sides by 8. So if we divide both sides by 8, we are going to get 5 over 2. Just use your calculator there just to confirm that. So that is your answer. The value of x, it is 5 over 2. So therefore, others are likely to write it in decimals, but it's okay even if you did not, you left it there, unless the question stated clearly to say round off your answer to 2 decimal place. And yes, so that will be also 2.5 units. Okay, so that is you now applying the theorem that the converse theorem of the first theorem that you learned in the previous video, please, in lesson 2. So now again, I want us to look at the last theorem, not of the same kind or associated with the ones that we just learned now. So this one is not much practiced, but it is also there. It's also good to know about it because it might be somehow structured within our questions. Just say perpendicular bisector. We just have to know that the perpendicular bisector, it's a line that forms a 90-degree angle. It forms a 90-degree angle. So it forms a 90-degree angle, and after that it divides the line into two equal parts. Let's call this AB. So OM. So the line OM forms a 90-degree angle with AB, so they are perpendicular. So bisector, it cuts the line AB in half. So we are saying that the perpendicular bisector of a chord passes through the center of the circle. How do we know that any line that bisects the chord and is perpendicular to that chord passes through the center? So let's look at this. This is what the theorem is saying. The perpendicular bisector of chord passes through the center of the circle. So forms 90-degree angle and it divides that chord into two equal parts. We might have learnt about this radius, you see, if we radii, sorry. So if we draw our radii OA and OB from the center O, we would realize that this line, okay, you can use that. This line is equals to this line. Obviously, we said it's a radii, but what is important there is to know that those OA and OB, they are equidistant from a common point center to the chord. So what would happen if we were to draw other two lines from the endpoints of the chord to any part of that perpendicular bisector? So we can even use what you call the congruency again to confirm that. So one, we have let's call this point M. Okay, I already used M, so let me use letter P. So choose any point on the perpendicular bisector. So there are two triangles now that are formed. So in triangle A P M and triangle B P M. In these two triangles, we are seeing that angle M1 is equals to angle M2. Both of them are equals to 90 degrees. Remember that the line OM is perpendicular to AB. That's what the theorem is saying as indicated on the diagram. So this is a given information, given that OM is perpendicular to what? To AB, as we can see from the diagram. And OP is not OP, sorry, it's not OP. is PM rather. Okay. So PM is common in the two triangles. It's common. You can easily see there is our PM, there is our PM again. And what else? We are given that AM is equals to MB. So MB, we are given that these two are equal. So that's why it's a perpendicular bisector. So we just want to check if it lies, it passes through the center rather. So A, it's also given. It's given. Then now we have an angle, a right angle triangle, and we have a common side. We have another side. If we look at the sides, PM, is it not necessarily? So we have a right angle or an angle and a side and side. So we'd say triangle APM. Remember, the order is important here. Although the way I have arranged them, the order is already being followed. So PM is the last two letters. AM is the first and last letter. So it will be BPM. See, PM is common, PM is common. AM and BM, they're there. So this would say it is the side, the common side, and the 90-degree angle is in between the sides. So you see that. So it's side, angle, side. So we have proved that the two triangles are congruent. So if the two triangles are congruent, therefore PB must be equals to PA. Do you see that? The line PB is equals to PA, which we also confirmed about OB radii are equal in length, and they are coming from a common point, the endpoints of the chord AB. So any line that runs from the endpoints of the chord to any line that passes through the center will be equidistant. So they will be equal in distance. So that's how you'd prove this theorem. Otherwise, it is not mostly, I don't know, I wouldn't say examined, but yeah, it is not stressed much, but it is also important to know about this theorem. So just do more practice and it gets better as you do something each day that is associated with geometry or maths in general. So keep in touch with your books. Please, I hope you just understood what we did to on this video. So subscribe, share, and yeah, just do the maths. Thank you for watching.